What's up everyone, Tom here, and sometimes you just have to let it go. And that's exactly what I'm going to do today with my old, tired workhorse of a 3D printer, the Mendel90. And to pay the last respects to this trusty machine, I kind of want to give you a rundown of how I built it, what kind of decisions went into it, and which parts worked out well and which didn't work out so well. It's been my most used 3D printer, but also the most modified one, so it's in a really bad shape right now. Let's start out with the basics. This was my third 3D printer that I built for myself after using a stock Prusa Mendel i2 for a while and then cheaply converting that to a standard Mendel90 to see if that concept would work out at all. And it turned out the Mendel90 is actually a pretty darn nice machine. So in mid-2012, I set out to build this one. And the awesome thing about this 3D printer is that because Knob had actually designed it completely in OpenSCAD, it could just change the parameters to larger or smaller rods, to different belts, to a different build volume, and it would generate a complete set of printable parts and cutting templates for the frame and the bed subframe. So obviously I wouldn't just build another standard sized 3D printer. It had to be large. Double-sized in fact, and using 18mm plywood instead of 10mm MDF. I basically designed it around having two heater PCBs in here. These are two standard PCBs glued together with a high temperature, high strength epoxy. And that had it ending up with a build volume at a bit over 400mm wide and 200mm deep and tall. The other thing I wanted to eventually do with it was to use it as a super light duty CNC router with a Dremel. But even though I used 12mm steel rails, when they're spanning over 500mm, they're everything but solid. They actually perform a lot like 8mm rails in a regular size printer. Also, I simply grabbed ground stainless steel bar stock for these, which was a mistake, as the LM12U linear ball bearings drive ridges into that material incredibly easily. So the other thing I did to make the motion system a bit stiffer was to use these 15mm wide HTD belts. They are the same family as the common GT series belts, but are made for lower loads and as such are a lot cheaper, and these in particular have a 3mm pitch. I used some fairly small aluminum pulleys to give the maximum stiffness and torque from the motor. I had started out with 3D printed pulleys, but they just never ran true and ended up breaking as well. The Y-axis on this Mendel90 actually uses two belts and two stepper motors, each with their own driver, because the bed assembly is actually really heavy. Of course, the heater PCBs and the glass I had on there originally did add a bunch of weight, but the undercarriage is much too heavy too. It's made from 6mm thick FR4, so the same material as PCBs are made out of. And that performs basically like carbon fiber, costs 50% less, but also adds 50% weight for the same dimensions. Now the bed is incredibly stiff, that's not going anywhere, but the weight did run me into a few issues. The toughest one being resonances, and I've been sensitized for them ever since. Basically, when you're printing an area with short back and forth strokes for infill, you are eventually going to hit just the right frequency to get that entire axis assembly resonating, and at that point your stepper motors are going to skip, nothing you can do about that. So as a consequence, the Y-axis runs on really low accelerations and thus slow down the entire print. And the part that I figured this out on were the links of these drag chains. There's one below the Y-axis, and there also used to be one for the X-axis, but I took that one off since I thought it was causing some weird artifacts and irregularities that I thought originated from these drag chains, having drag. Turned out it was the filament actually pulling up on the extruder, so after I added that reverse Bowden tube, it started printing a whole lot better. Now on the topic of extruder and hot end, right now it doesn't have either of those. It started out with a Tom's Greg's Wade's extruder, but almost every single hot end or extruder I've tested over the years was mounted in this very printer, and as a result this carriage area is now an utter and complete mess. It was never intended to be as heavily modified and tinkered with as it was, so there are no connectors in here other than these pin headers. It is not modular at all, and as you can see, it's even got a few boost converters dangling around in there, I believe from testing the dies NX. If I end up rebuilding this, it definitely needs a complete redesign. So as we move around the printer, you can see the general idea of all the paneling around the frame. Now, the Mendel90's frame is awesome in that regard because it is basically box shaped. You can lay it down flat onto either side, and I decided to close off all sides with some more plywood. The left and right sides are mostly closed with some vent holes for the power supply and for the electronics. The back is home to a filament rack. The top has this cutout for the filament to enter the printer, as well as a reflective surface for the RGB and white LEDs to illuminate the printer from the inside and to provide a bit of status information. And the front was going to be a plexiglass panel, but I never got around to properly attaching that, since I wanted to eventually build it with a hinge assembly that would like swing it up like this instead of just a simple hinge on top. Most of the time though, I used it like this with the left and rear panel installed and everything else removed, since I needed to regularly get to the electronics in this rear right column. Now, electronics and mainboard. So in here is an Arduino Mega plus a RAMs, and if you've been watching my videos, you'll know that I can't really recommend this setup to anyone. But it's still okay that I use it, because it has very little to do with what the RAMs boards typically look like. I'm not using the onboard MOSFETs for the heated bed or heated beds at the time. I've got the second Y-axis motor driver wired in somewhere, and there are a few changes to the power delivery on top of that. Overall, it doesn't have all that much in common with your $6 RAMs board from AliExpress anymore. Next to it, there is just barely enough space for a Raspberry Pi, as well as a fan to cool the stepper drivers. Now, the actual high current magic is happening in the other pillar over here. There is an 850 watt 80 plus silver ATX supply in here, which did cost 80 euros at the time, but I'm sure the better efficiency much more than made up for the premium upfront over the lifetime of this printer. And I didn't want to just chop up the wiring, so I made an adapter PCB that the PCI Express and ATX connectors plug into, and that PCB is also home to the two MOSFETs for the heated beds, so that I wouldn't have to route 30 amps from the left column to the right one and then all the way back up to the heated beds. Oh, did I mention there's a 3D printed cable channel in the back and a webcam integrated into the front of the printer? No. Alright, so that should be a good overview of what this machine is all about. Now, what would I change when rebuilding this? Well, quite a bit. So starting with the most drastic part, the double heated bed. Now, these two are set up to be completely independent from each other. They have their own control MOSFET, their own thermistor, they are controlled independently in firmware, and when I wanted to save some power for a smaller print, I was actually able to heat up just one and leave the other one completely cold. This gave me a 12 to 15 centimeter wide strip on the edge of the glass that was mostly the same temperature. However, I had to make some severe changes to Marlin to actually be able to control two beds. Usually you have one or more hot ends, but not individual bed heating zones. So I ended up never updating Marlin and was stuck with a version from like mid-2013. A lot changed since then. Eventually I swapped in this 150mm aluminum bed that was intended for the Cerberus, and not only was it a whole lot faster, but it also turned out that size was plenty, since I wasn't really used to having a usable large printing envelope anyways. So I'm not sure if I'd pursue a split zone heater again, maybe with a lot of thought going into it, but having a large aluminum one, maybe insulated on the bottom even, is probably the smarter way to go. Next up, linear motion. 15mm belts and 12mm rails, pretty sweet. I'd do that again any day. But only with proper hardened rails. In fact, the Z-axis has already been upgraded to chromed and hardened rails. The Z-axis couplers commonly called plumb couplers, link in the video description to these, turned out to be pretty awesome. They have zero longitudinal play and are actually stiff enough to guide your threaded rod or whatever else you want to be using there, instead of letting it wobble around. And as a result, this printer has nearly zero Z-wobble. And the stick frame works perfectly since it's primed and painted, it never warped, and provides plenty of strength to the printer. What I will definitely need to improve though is the wiring, as if it weren't obvious enough. But as it stands, it has no flexibility. As soon as I tried to change a single thing, I'd have to dig through layers of wires just to find which one did what. And there also aren't any proper connectors on them. At most, soldered pin headers, which are anything but ideal connectors. Though I have to say, the printed drag chains are pretty neat, even if I did question them along the way. When I rebuild this, I am definitely going to put them all back into place. But by far, what got me to use this printer a whole lot was the Raspberry Pi Plus Octoprint in here. Having the Pi integrated and always on, supplied by the 5-volt standby rail of the ATX supply, made it incredibly comfortable to quickly print something. I knew this printer was completely reliable, so for most prints I didn't even have to come down here at all until the print was finished and ready to be picked up. The mainboard would turn on the rest of the power supply and the LEDs, so I could watch the entire process in a browser window, and when it was done, it turned the power supply off again to save power, but it was always ready to receive the next printing order. So, as I said in the breakdown of the Service Reborn, I'm not sure if I'm going to immediately rebuild this thing, but something definitely needs to be done. As of right now, it's in no shape to be useful. It does still print if I put an extruder and hot in here, but everything about it is just not in good shape. Alright, so that's the quick version of what my Mendel90 is all about, and the first and last time I'm showing it on camera in this state, in this sort of detail. So if you've been wondering why you only ever saw detail shots of it, yeah, that's why. I hope you found this video helpful or at least interesting. If you did, I'd appreciate a thumbs up. If you didn't, a thumbs down. If you haven't done so already, get subscribed, and you could consider dropping a $1 or $2 directly on Patreon. And that's it for today. See you in the next one.